In this video, I will go over how to do numbers 1 through 4 of the APES-Energy-Math. Number 1. How you solve number 1 is you take 300 million, and I suggest using the word million instead of writing out zeros. But if you use the word million in your problem, make sure you also use it in your answer. The problem tells us that it's 24 barrels per person, so write it out with barrels over one person. And your answer is going to be 300 times 24. And remember, on the AP test you cannot use a calculator, so make sure that you solve it just off to the side somewhere. 300 times 24. Go ahead and do the math like that, and you end up with 7,200 million barrels per person, which is per capita. So that's our answer, but that's a very bad way to write it. 7,200 million barrels of oil is better written. You can go from million to billion by moving the decimal point back 1, 2, 3. So really a better way to write this is 7.2 billion barrels per person or per capita. So this is the better way of writing the answer. But you know, on an AP test, if you left it at 7,200 million, they would probably accept it. Remember, you had the word million in the problem, so make sure you transfer it to the answer. If you just write the word 7,200 without million, it is an incorrect answer. So make sure you write the word million because you left it in the problem. Number 2. Let's go ahead also and take 300 million people again. And there's 480 cars per 1,000 people, which we can just write as persons. So persons, or people, cross out, and now we have 300 times 480, and if you do this math, you end up with 144,000 million cars over 1,000. So 300 times 480 is 144,000, and then 1,000 here, so divided by 1,000. And you'll notice this is a kind of an easy problem because we can just cross out our zeros here, and so it's 144 million cars. And that's our answer here. Number 3. How you answer number 3 is you have to first solve for both cars and find out basically how many gallons it takes to go 800 miles on each car, and then find out the pounds of CO2 it takes, and then find out the difference. So first I'm going to take the first car here, and I'm going to start way over here to give myself some room. And it's going to go 800 miles, and it's only getting 20, I'm sorry, I'm out of the camera range there, 20 miles per gallon. And so if you take 800 divided by 20 miles per gallon, the gallon actually flips up to the top here and the miles cross out. Okay, and so we end up here with 40 gallons of gas it took for car 1. The hybrid car that gets 45 miles per gallon, 800 miles divided by 40 miles per gallon, that's wrong, it's 45, and that's going to end up at 17.78 gallons. So in our problem, it tells us here that 5 pounds of carbon is released per 1 gallon of gas. So I'm going to take 40 gallons of gas times 5 pounds CO2 per gallon. And that's an L, by the way. I'll make that a cursive L to help us here. And so that's also here times 5 pounds CO2 per gallon. Now our gallons cross out. 40 times 5 is 200 pounds of CO2. 17.78 times 5 gives us 88.9 pounds CO2. So the question is approximately how much less carbon will be produced by the second auto. So now we subtract. 200 minus 88.9 gives us 101.1, and this is pounds of CO2. Don't forget to put units in your answers. Number 4. First of all, it tells us that we have 10 100-watt light bulbs. So 10 times 100 watts times 5 hours per day. And so that's going to give us 10 times 100 is 1,000 times 5. It's going to give us 5,000 watt hours per day. Now I'm going to take this and I'm going to convert it to kilowatts because our answer has to be in kilowatt hours. And so there's 1,000 watts in a kilowatt. So this is just really easy to figure out. This is just 5 kilowatts. But if you were to wanted to set it up, you would say 1 kilowatt is equal to 1,000 watts. And so now our watts cross out, and now you have 5,000 divided by 1,000, and that's going to give you, equals, I'm going to go down over here, give myself a little more room. So I'm going to get here 5 kilowatt hours per day. Now that's per day, but the question asks in 1 year. So now I'm going to have to take 5 kilowatt hours per day and multiply it by 365 days per year. And so 5 times 365, and again my days cross out, and my answer is 1,825 kilowatt hours per year.